We're going to now look at perpendicular lines, lines that meet each other at a right angle. Example 1, given that T is the point 1 minus 2 and S is the point minus 4, 5, find the gradient of any line which is perpendicular to ST. Well, first of all, let's find the gradient of ST, so that will be given by y2 minus y1 over x2 minus x1. So that's 5 minus minus 2 over minus 4 minus 1. 5 minus minus 2 is 7. Minus 4 minus 5. Minus 4 minus 1 is minus 5. I then know that this relationship works. M1, M2 equals minus 1. So basically in practice what that means is that I get the value for the gradient, I flip it and change its sign, and that will give me 5/7. And that works because 5/7 multiplied by minus 7 over 5 will give me minus 1. So the final answer for this one will be 5/7. Example 2, I'm looking to prove that this triangle is right angled at O. Well, I can use perpendicular lines to prove this. So I'm first of all going to find the gradient of OM. So that will be 9 minus 0 over minus 3 minus 0. 9 minus 0 is 9, minus 3 minus 0 is minus 3, 9 divided by minus 3, and the gradient of OM is minus 3. Let's now investigate the gradient of OP. So that will be 4 minus 0 over 12 minus 0. That's 4 over 12, and that's equal to 1/3. So we can see then that that relationship holds up. So minus 3, we can think about that as minus 3 over 1 and 1/3. That relationship of flip the fraction and change its sign. So let's formalise this with a final statement. Minus 3 multiplied by 1/3 is equal to minus 1, so it shows that that relationship works. Therefore, triangle is right angled at O. You should note that M1 times M2 equals minus 1, and this combined with the fact that you flip the fraction and change its sign, it works for all lines except for vertical and horizontal lines. The gradient of a horizontal line is 0, and the gradient of a vertical line is undefined. Another word that we could use for that is it's infinite. But the relationship of M1 times M2 equals minus 1 and flip the fraction, change its sign does not work for only these examples, vertical and horizontal lines.